question number 4. Our fourth problem on the topic of friction. I'll read the question. A stone of mass 500 kg is resting on an inclined plane of 60 degree, full stop. If coefficient of friction is 0.4, comma, find out if the stone will be stable or not. So here I have a question in which the diagram is not given, but some hints are provided. With the help of that, we can draw the diagram. So let us start with writing the data for this question. Here in this question, a stone of mass 500 kg is resting on an inclined plane of 60 degree. Means here we have a inclined plane of 60 degree. Over that a stone is kept. This is a stone. Mass of the stone is given as 500 kg. M is equal to 500 kg. Next, if the coefficient of friction is 0.4, that is the coefficient of friction between the stone and inclined plane, M is equal to 0.4. Here we have to find out if the stone will be stable or not. The meaning of stable is that this stone will not fall down from this surface. That is the meaning of stability, that it should remain at its position. So we have to calculate that if the stone is stable or not. That's the question. Now, how to solve this problem? Since mass has been given, I'll write the solution first. Solution. Since mass is given, I can say that weight of the stone, capital W, is equal to M into G, which is mass into acceleration due to gravity. Therefore, capital W will be equal to 500 into G is 9.81. Hence, my answer of W, that comes out to be, it is 4905 Newton. That is the weight of the block. Now, once we know this weight of the block, we can show it on the diagram. Weight would be acting vertically down. Here we have W. Value is 4905 Newton. We have calculated. Now, since we know that inclination of weight which is acting vertically downward, its inclination with this vertical line will be same as the inclination of the plane, that is 60 degree. So here we have two components of weight, one which is parallel to the plane, other which is perpendicular to the plane. The component which is parallel to the plane, we can call that as W, which is 4905 Newton. It will be sine 60 because inclination is with vertical. So horizontal component will have sine term. And this component which is perpendicular to the plane, it will have 4905 cos 60 as its value. I hope you all are getting this. Next, 4905 sine 60 degree. Because of this component, the stone will be sliding downward, but friction force will try to opposite, which is mu into Rn. It means the motion of the stone that is in the downward direction. So here we have to see that since it is moving down, if it is stable or not, means if it is falling or not. See, for this we need one condition. Now what is that? First of all, what I'll say, here 4905 cos 60 is acting perpendicular in the downward direction. Opposite to this, there will be normal reaction, which is Rn. This question is a conceptual question in which we can say that this stone will be stable only if the friction force is more and 4905 sin 60 this value is less, because the stone will be unstable because of this force of 4905 sin 60, means horizontal component of weight that is along the plane. Because of this force only the stone will be sliding downward, but if we have friction force value more than this component, then we can say that the stone is stable. So now let us try to get this problem. I will be concentrating on calculation of friction force. So I will say that consider the stone to be in limiting equilibrium. I'll say that sum of all forces parallel to the plane should be taken equal to 0. Therefore, I'll say that it is, since the sum of all forces parallel to the plane, you can treat it as summation fx, that should be taken as 0. All upward forces along the plane positive and all downward forces along the plane negative. Therefore, if I look in this diagram, F is acting upward, so positive. 4905 sin 60 acting downward, so negative, and that should be equal to 0. Here I'll say that therefore capital F is equal to, I will shift 4905 sin 60 onto the other side. So hence I would be getting this value. In this I can say that therefore this F is also equal to mu into Rn, which is equal to 4905 sin 60. Next, I need to know the value of Rn here, so I'll keep this as equation number 1. After this, I would be saying that sum of all forces perpendicular to the plane, that should be taken as 0. So in other words, summation of Fy is 0. All forces perpendicular to the plane positive, all forces perpendicular to the plane downward direction negative. So hence I will be getting here Rn is equal to 4905 cos 60, Rn minus 4905 cos 60. So hence that is equal to 0. Rn will be, I am getting the answer of Rn, that comes out to be 2.45 10 raised to 3. Hence, I will be getting my answer of frictional force. Therefore, frictional force capital F is equal to mu into Rn. So I will say that therefore capital F is equal to mu is 0.4, Rn is 2.45 into 10 raised to 3. Hence, I will be getting my answer of capital F, which comes out to be 980 Newton. After getting frictional force, this is the frictional force. Now we have to find out the force which is causing the sliding of this stone downward, and that force is 4905 sin 60. So I'll say that therefore component of weight which slides the stone downwards is given by, so that component is 4905 sine 60. That is 4905 sine 60. I will call this as a force which is acting in the downward direction. Now, if we look at this value, I will be getting my answer as 4.25 10 raised to 3 Newton. Now, it is very easy to compare. Here the question was we have to calculate if the stone is stable or not. This stone which we have here, it will be stable only if the friction force is more and 4905 sine 60 this value is less. So we have to compare both the terms now. I will say that since F downward this force is greater than the frictional force F, it means the effect of friction force is less and the effect of downward force is more. So because of the effect of this downward force, the stone will be sliding downward, that is, it will be unstable. So I will say that therefore stone will be unstable, and that will be our answer, because in this question they were telling us to just say that if the stone will remain stable or not. Now we have seen the frictional force is less, downward force is more, and because of this downward quantity the stone would be slided in its direction. And with this we complete the fourth problem.